We have chapter 1.3. The first part is filling in vocabulary. Whenever we have our equation equal to a constant, we call that a constant function. Here, y equals x is a linear function. Specifically, if there's nothing else added on here, like the m and the plus b, when y equals x, because remember that's what f of x stands for, is our y, this is called a specific identity function. So if y is 2, x is 2. Y is -1, x is -1. So this is actually a very specific identity. When we have f of x equals absolute value of x, we call that an absolute value. Next one, we square root. Most of these we should be very familiar with. A quadratic and a cubic. We've heard all these words before. We've looked at all of them. We've seen all of them. But what we're going to start doing is looking at their graphs. Now, in last chapter, we just had an introduction. What do the shapes look like? Now we're going to start looking at how do we move them? What are those h's and k's that we kept talking about? So here we have graph of f of x equals x squared at the right, and see what happens if we do these things added and subtracted and to them. Alright, so first of all, you want to see what is y equals x squared. We can use our calculator, y equals x squared. And we should be very familiar with a general parabola, y equals x squared. Something like that. Alright, so what happens when we take this x squared, because that's what f of x is. It's x squared plus 2, because f of x is x squared. So x squared plus 2. If I were to put that in the calculator, y equals x squared plus 2, and see what the graph looks like, we see that it actually shifted my whole picture up 2 units. See how it went from the origin up 2? So f of x minus 3, what would you think to conjecture if now that's x squared minus 3 on that? You should hopefully put it together that it would shift my original y equals x squared, that it would shift it 3 units down. That's what we're going to conjecture, but let's go and just double check it. Minus 3 into the equation. Look at the graph, and notice it did take our origin parabola that we have here, and it shifted it down 3 units. Alright, on this next one, it says I'm going to plug in the x minus 2. Remember, this is all substitution. So I have my x minus 2 into is going to be squared. And if I look at that picture, parenthesis, x minus 2 parenthesis squared, look at the graph. Notice that it moved it off of the origin to the right. So this is going to be shift to the right 2 units. And right is positive, if you want to think of it that way, positive 2 units. Again, there's the picture. Took it from the origin and took it to the right 2 units. So what conjecture would we think if it's x plus 3 squared? And again, we're plugging the x plus 3 into the x location because it says f of. So that means that x is being replaced with the x plus 3. X plus 3 squared. if the -2 shifted positively, what may think the +3 might shift? Hopefully, we think that it would shift to the left, or -3 units. But let's check them. At the picture here, y equals, and we're going to put in x plus 3. When I graph it, x plus 3, there's my equation. When I put in the x plus 3, notice it did move it off of the origin over left, or to the 3 negative units. So what can we conjecture about being able to add or subtract something to the back side of a square, or being able to actually put something inside of a square? This is where we start throwing in our h's and k's. We're going to get y, and then we have x minus h squared plus k, where the h is going to shift left or right the opposite sign, and k is going to shift up or down, but it's going to be the same sign. So here it was +2, so it went up. It was the same sign. On the inside here it was -2, so it went opposite.